Hi class, in this recording we're going to be covering PhysioEx exercise number 6, activity number 2. We're going to be focusing on the effect of the vagus nerve on the heart and heart rate. To review, the vagus nerve is cranial nerve number 10, and it's going to be the primary nerve of the parasympathetic nervous system to the heart. So this vagus nerve, and vagus is for a root word that means vagabond or wanderer. The vagus nerve wanders all over the body, particularly the abdominal pelvic cavity, and has parasympathetic reflexes. Also to review, our parasympathetic nervous system is the rest and digest branch of the autonomic nervous system, whereas the sympathetic nervous system is the fight or flight branch of our nervous system. So as we're looking at the sympathetic and parasympathetic nervous systems, they influenced heart rate. In particular, the vagus nerve stimulation, the parasympathetic stimulation to the heart, lowers the heart rate. And eventually, if we have excessive stimulation, the heart can stop beating. After the heart stops beating, though, the heart starts beating again after it stops beating. And this process of overcoming excessive vagal nerve stimulation and reinitiating the heart rate is called vagal escape. It typically is going to happen either because of sympathetic nervous system reflexes or the Purkinje fibers located in the ventricles becoming autorhythmic. In our heart, in the right atrium, we have a sinoatrial node, and the sinoatrial node is the pacemaker of the heart. We refer to it as the pacemaker of the heart because the cardiomyocytes that make up the sinoatrial node have the highest frequency of depolarization. So they typically are going to dictate heart rate, and if it was up to just the pacemaker cells, we would have a heart rate of approximately 100 beats per minute at rest. And during our experiment, you were given this experimental setup. So you had a heart with some electrodes, and you grabbed a vagal nerve stimulator and hooked it up to the heart and hit go. And it looked something like this. We're gonna Let me go to our experiment. We had our EKG right here, or ECG right there. And if I stimulate the vagus nerve, or the artificial vagus nerve, the heart rate, there we go. Let me try again. The heart rate starts to slow down from that multiple stimuli. Here we go. Now it's actually working. So the heart rate's going down, lower, lower. He's getting calmer and calmer and calmer. And he flatlines. So this is excessive vagal nerve stimulation. And to simulate vagal escape, we stop stimulating the vagal nerve, and then the heart rate starts up again. So vagal escape is when we start beating the heart again after the vagus nerve makes us stop beating the heart. Now, let's look at our post-lab questions. On our weekly objective sheet, you were asked to do all of the questions by default. We didn't tell you to skip any of the questions. So let's go back here. Describe how the stimulation of the vagus nerve affects the heart rate. Well, the vagus nerve lowers heart rate. Excessive stimulation of the vagus nerve will stop the heart from beating. Question number 2. How does the sympathetic nervous system affect heart rate and force of contraction? The sympathetic nervous system increases heart rate and increases force of contraction. Now, let's keep in mind something that a lot of students get wrong with the vagus nerve is they think that because the vagus nerve is part of the parasympathetic nervous system, that it reduces force of contraction. That is not true. The parasympathetic nervous system focuses on only reducing heart rate. Sympathetic nervous system is going to focus on increasing heart rate and increasing force of contraction. In terms of describing the mechanism of vagal escape, the mechanism of vagal escape is associated with the vagus nerve stimulation being reduced and the sympathetic nervous system reinitiating heart rate, the heartbeat, or the Purkinje fibers reinitiating the heart rate. As we look at the heart rate, if the vagus nerve was cut, so the baseline heart rate before you had the vagus nerve connect, that baseline heart rate is higher compared to when the vagus nerve is disconnected and not being highly stimulated. This implies that the vagus nerve is always giving some low-lying stimulation to the heart to help reduce the heart rate while we are at rest. Otherwise, if it was up to just the sinoatrial node, our resting heart rate would be about 100 beats per minute. And thank goodness our resting heart rate is not 100 beats per minute. That would not be enjoyable. And I just want to make sure we cover all the questions. We're good. So that's everything for PhysioEx activity number 2, exercise 11, exercise 6. Brain hiccup there. PhysioEx exercise 6, activity number 2. If you have any questions or comments, please feel free to post them in the class discussion board. And as always, happy studies.